Hello and welcome to the Analog Devices Precision Training video, which focuses on switch and multiplexer technology. This video is the second in the series. Discussed are the specifications relating to Orion and what should be considered when reviewing these specifications. We will highlight parameters that influence the Orion value of a switch and go through the key considerations when using a multi-channel switch or multiplexer and show how the Orion affects the precision performance of a switch. A number of factors influence the Orion characteristic of the switch: supply voltage, temperature, and input signal voltage. The plot shows how the Orion varies with supply voltage, temperature, and input signal voltage. It can also be seen that as the supply voltage decreases, the on resistance increases. The on resistance, or oron, can increase or decrease with an increase or decrease in environmental operating temperature, and also varies when applied input signal voltage varies. These nonlinear resistance characteristics that are introduced can cause errors in the switch's DC accuracy, as well as the AC distortion in system design. When using a multi-channel switch or multiplexer, an important specification to consider is the or-on matching between channels. This is also known as delta or-on. This specification is used to show how the or-on differs between the channels of the multiplexer. If we take a switch with an or-on matching specification of 0.1 ohms typical, this means that the most the or-on of the channels will vary from one another is 0.1 ohms. This specification becomes important in applications where the resistance of multiple signals paths must be kept as similar as possible, reducing measurement mismatch errors. Such an example of this is in the design of a differential system. Another switch specification that is important to consider is the or-on flatness. The or-on flatness specifies how much the on resistance, or-on, of the switch varies in relation to the applied input voltage. Here we show a plot that presents the switch on resistance, or-on, versus the applied input voltage that passes through the switch. In blue, we show a switch that has higher or-on. It can be seen that the or-on varies significantly over input voltage range. This variation of resistance affects the total harmonic distortion and noise specifications of the switch, also known as THD plus N. The second plot in shows a switch that has a much lower or-on specification. It can be seen that the profile of the or-on is also much flatter when compared with the previous plot. This improved or-on flatness allows for a superior THD plus N specification, enabling the switch to achieve excellent linearity performance when compared with the previous plot. Analog Devices has many switches available with low on resistance and great THD plus N performance.